In this lesson, we're going to talk about how to find the inverse of a function, and I have two methods for you. The first one I call the list method, and it's not in many books, but I like it best. And the next one's called the four-step method, which is in our textbook, so I will show you that as well. That's my favorite. Now, we need some new notation. We need a way to write f inverse. So the inverse of f of x is written f, it looks like to the -1 of x. That -1 looks like an exponent, but it is not. So when we see it, what looks like f to the -1, we actually read this as f inverse of x. That's f inverse of x. And that just means the function that works backwards from f. So now let's find f inverse for f of x equals 2x minus 9. And we'll use the list method. So what we need to do is make a list of each of the steps that's happening to our x. In other words, I want you to imagine if you had to plug in a number for x, what would you do to that x to calculate this value? Well, the first thing you would do is you would multiply it by 2. So let's write that down. And then you would subtract 9. So let's write that down. So these are the things that are happening in my function. Now the inverse function will have to undo each of those things, but it will have to undo it in the reverse order. So first we have to reverse minus 9. And to do that we need plus 9. Then to undo times 2, we'll have to divide by 2. So your inverse function has to be built from the bottom up. So you just look at each step and say, what would it take to reverse this? You write it down. Then go up the list. What would it take to reverse this? And you write it down. Now we have to build our inverse function using these steps. So we will first write down an x, and then we will do this to it, plus 9. And then we will do this to the whole expression, divided by 2. So here is our plus 9 and our divided by 2. And this is the inverse function. Now let's try that same thing with the four-step method. So the four-step method involves these 4 steps. First we replace the f of x with the letter y, just because y is easier to write. Then we switch x and y. That is actually what accomplishes the inverse, because if you make the function work backwards, if the input becomes an output and the output becomes an input, then you've made the function go backwards, and so now you have an inverse. So what you have to do is solve it for y and label it as an inverse. So now let's find f inverse for f of x equals 2x minus 9. And here I've already done the first step. I've replaced f of x with the letter y. Now in step 2, we will literally switch places with x and y, not the terms, just the letters. So the y becomes an x. And then here where I had 2x, that's going to become 2y. Nothing else changes, just switch places with x and y. Now we solve for y. And there is our inverse function. We just have to label it as an inverse function. And if you'll remember, it's the same one we got when we did it by the list method. So now that you've seen both methods, you can choose which one you prefer and which one you would like to practice with. So now let's find f inverse for f of x equals 3x plus 8. And we'll also do f of x equals x to the third plus 6. Now let's use the list method. So first I look at my x and I say, if I had to plug in a number for x, what are the steps I would take? Well, the first step is I would multiply the number by 3. And the next step is I would add 8. Now to reverse that, first we have to reverse plus 8, so we write minus 8. Then we have to reverse times 3, so we write divided by 3. Now we have to write our function. So f inverse is going to be x minus 8 divided by 3. And notice that the second step works on the entire expression. And it's that way all the time. Every new step works on the entire expression that you already have. So now let's try this one. We'll make a list. We'll say the first thing you would have to do if you plugged in a number for x, you would cube it. Now this is how I write to the third power. That caret symbol, that housetop looking symbol, usually in computer languages is used for exponents, so we can use it here. It's just a little shortcut, shorthand method to write third power. And then the second thing I would do is add 6. Now let's make our list of inverse steps. First I have to reverse the plus 6, and then I have to reverse the third power. Now you might not have thought of it yet, but the reverse of the third power is the third root. So I'll write it like this, a radical with a 3 index. Okay, now let's go ahead and write f inverse equals, and we've got our x here. Well, the first thing we have to do is minus 6, and the next thing we have to do is the third root. And that's all there is to it. We can look at those same two functions using the 4-step method. So here's the first step for 3x plus 8. Take out f of x and replace it with the letter y. In step 2, we switch the x and the y. So all I've done is write x where I used to have y, and write y where I used to have x. Now I will solve for y. So I've subtracted 8 from both sides, and now divide both sides by 3. There's your inverse function, and in step 4 all you do is replace the y with an f inverse. Okay, now on this one, let's replace f of x with the letter y. Let's now switch x and y, so it will say x equals y to the third plus 6. Now let's solve for y, so we will subtract 6 from both sides, and we will do the cube root of both sides. There's our inverse function, and all we have to do now is label it with f inverse. Let's do f inverse for a couple of other functions, and we'll just use the list method because it's very straightforward. So on this first function, if I plug in a number for x, the first thing I'm going to have to do is add 3. And the next thing I'm going to do to that answer is raise it to the 5th power. Now to reverse that function, first I have to undo the 5th power, so that would be the 5th root. Next I have to undo the plus 3, so that's a minus 3. Now let's write our function. So I put down an x, then I do this to it, that's 5th root, then I do this, that's minus 3. Notice in this case, because the minus 3 came after the radical, it's not under the radical. That's our inverse function. Now let's work on 4 over x plus 3. And you might be wondering, how are we going to write down how to get the x in the denominator? Well, if you think of it as a negative 1 power, it's really not that hard. So now you can probably see that the first thing I have to do to my x is the negative 1 power. The next thing I have to do is multiply it by 4. And the next thing I have to do is add 3. Now to reverse that, the first thing we have to reverse is plus 3. That's a minus 3. The next thing we have to reverse is times 4. That's divide by 4. The next thing we have to reverse is the negative 1 power. Well, we talked about earlier how powers and roots are the reverse of each other, but in this case, what does it mean to do the negative 1 root? Well, it really doesn't mean anything. So think about this. If you do the reciprocal of a number and you want to undo that, you just do another reciprocal, right? So the negative 1 power is what performs a reciprocal. So here I need to undo a reciprocal, so I'll just do another reciprocal. So another negative 1 power. This is the only power that is its own inverse. Most of the time we do have a power and a root acting as inverses. But in this case, because the reciprocal is its own inverse, we see it both places. Now let's write down our function. So we'll start with x. And first we will subtract 3. And then we will divide the whole thing by 4. And then we will do the reciprocal to the whole thing. So rather than leave it with the -1 in place there, let's go ahead and work out that reciprocal. So it would be 4 over x minus 3.